Hi and welcome to the channel. My name's Ray Whitby and I'm your host. In today's video we're going to be looking at wood turning a segmented helix. Now I've not actually come across it myself, it's not to say that it hasn't been done before, but I really do hope you enjoy this particular video, not just for its technicalities but also for the final effect. Because I've not actually done this myself before, I'm not seeing anybody else do it, it is a prototype, so I've had to come up with a lot of technical workarounds on the hoof and decided that the best thing to do was probably make it out of some inexpensive scrap white wood that I had lying around the workshop. So the first thing I had to do was, obviously apart from getting all the pieces straight, was then to make a series of segments at a particular angle. And we're going for an unusual ring which will require 12.5 pieces per helical turn. Once all those segments are cut out, the wedges, it's then on to the bandsaw, and here is a custom-made jig that's absolutely vital in order to make the helix work. The idea is that the piece, the segment, will rotate about its center point as it's being pushed through the bandsaw, with the whole effect being that at the front of the piece will have a helical angle of 3 degrees, and by the time it's got to the back of the piece it should be 5 degrees, because as you know, if you take a hollow cylinder, the helical angle on the outside is less steep than the one on the inside. Now you may not be able to see it from this particular shot, so maybe you'll just have to take my word for it, but if you ever do try it you would suddenly see what it is I'm talking about. So whilst we've processed all these segments of equal height, I also needed some bigger blocks in order to build the starting base. And here we have it. This is the only time that I actually needed 12.5 segments in order to make a complete ring. And whilst it is only a sacrificial ring, it still required some technical precision in order to make sure that the subsequent segments that went on it did fit into a near perfect helix. And what we can do from forming that initial ring is to then sand it using a couple of the segments with a piece of sanding paper glued to the base. And this just ensures that when you're sanding you still maintain that varying helical angle throughout. Now this is a quick product review of Starbond, who had sent me a number of different types of CA glue that for me to trial out, so I'm just getting to grips with it, and initially my thoughts were, actually I quite like the packaging itself, and it seems to be a very low to no mess system, which I really do appreciate for CA glue. You can use a package just a little bit and then it just ends up gumming up the works, it solidifies, and then you've just wasted all your money from CA glue that you can't get access to. So the Starbond system so far seems to be a little bit superior to everything else that I've used, but you know, we'll be testing it over a few projects. Now you can, if you wish, also get a 10% discount by using the code, which will be in the description below. So just go along to Starbond, order the product, put in your code and get 10% off. I did say I only needed one set of 12.5 segments for a ring, but I actually needed two. I needed one for the base, from which the helix would be bonded to, and then a second one in order to deal with the top and mounting in the lathe later on. So this is the base that I'm going to use, and then we do a dry fit for the very first layer of the helix. If we're happy with the dry fit from the inside as well as the outside, observing that there are very few gaps, then what we're doing is just going to provide an anchor point for the rest of the helix to fill into the layer. I'm going to use a 15-minute epoxy resin glue, and we're dyeing it with black dye. I really wanted these segments to pop out in the final product. But one thing I didn't account for was just how much of the end grain would soak in some of that black dye, and unfortunately in the final piece it does look as though there's been a little bit of bleeding into the end grain, which is a shame. What I should have done was sealed everything with clear epoxy first, roughened it up a little bit with sandpaper, and then gone in with the black dyed epoxy glue. Once we have that very first piece anchored in, and that goes over the 11th and 12th piece, measured as carefully as we can. We've done the dry fit up to that anchor point just to make sure that it does fit in. Once we're happy with that, then it's time to basically use the epoxy glue as a mortar. So we dye quite a lot of the epoxy glue. We're using very fast acting curing resin. But it still allows us enough time to be able to reposition the pieces as needed. So they're just placed down almost like building a brick wall. They're laid down roughly with enough epoxy glue that they would leak out, so it's not a starved joint. And then we wrap around a lot of elastic bands as you would with horizontal segments. And I'm just putting in a few extra blocks because I really wanted the pressure to be on the center of each of these wedges as they're going around the helix. Once that helical layer is formed up to the anchor point, then we place the second ring on top, inverted, and then we can apply the clamps to give it some pressure whilst it's drying. And once it's dried, we can take that paper spacer off, and then I've just got a couple of blocks that are welded together with a bit of glue, and a piece of sanding paper has been adhered to the base, and we can use that to try and just smooth over any roughed edges or any deviations in the helix itself and try to bring it back in line. And if we're happy with the upper surface of the helix, then we can go again. It's just a case of anchoring one of the wedges between the last two wedges of the previous helix. Once that's secured in, just applying a lot more of the epoxy glue and providing those wedges and being quite liberal with it. Now here it's taking a hot glue gun to the other sacrificial template, and the idea is to then bind it to the rest of the helix in a way that it won't hopefully dismount when it's onto the lathe. So just using the remount jaws, and we're going to deal with the base of the helical structure. In not having a traditional horizontal segmented ring, I then have to create an aperture in which I can then slot in an exact diameter of a piece of wood in order to use as the base itself. And to this I'm going to apply mortise so I can actually really mount it properly into the chuck. Again, this is all scrap wood that I found around the workshop, so probably not the most nicest of looking of items in the end, but again it's all about the process itself and making sure that we've got a clear methodology that we could use next time. When the diameter's sufficiently correct, we apply a bit more epoxy glue, which is also dyed to match the rest of the helical system, and that should just slot straight into the aperture. And you can see from this shot that actually the thickness does vary around the base at the moment. I was not particularly careful when constructing the helix, and this is something that again I'll address in a future project. Again, not a major problem. As long as the pieces are thick enough, we should be able to get a defined shape other than just a simple straight cylinder. So we just remove that top sacrificial layer as the rest of the helix can now sit in a chuck and can be turned as normal. Thankfully the lathe work is actually done at high speed. I think if it was done any slower, I'd probably get mesmerized by the spiral pattern going around and around. In fact, maybe I could use it to hypnotize you. But actually, whether you like it or not, please do comment down below. Let me know what you think. If you've got any other ideas about how we could improve it, I'd love to hear from you. It took a while before we got the Helix into a cylinder. And the result was fairly good. Of course, the inside, the outside, both start off looking messy. It just takes a little while to chisel it away and then get down to the wood again. And as I say, this is where you actually needed to have quite a thick piece for each of the wedges, just so that you've got a lot of sacrificial area in which to work with. Now it's time to just tidy up that base, get it level with the insert that I have. Then we're moving into the very final stages of sanding it, starting at 120 grit, going up to 240, then sealing it, and then back on with 240. Do that for the inside and the outside of the Helix. And decided that to finish this project, I'd actually use a clear lacquer, both inside and outside. I really didn't want the piece any more yellow than it was. And now for the final product shot, we have the final Helix. As you can see, for me, there's some imperfections in the leaching of the black dye, the epoxy glue into the end grain, which I think detracts ever so slightly from it, but at least you get the beautiful effect of the Helix, a single continuous ribbon of segments forming here a beautiful vase. And actually, even the scrap white wood doesn't seem to have detracted too much from the aesthetics of it. Well, there's lots of things I could have done differently, always looking to improve, but I really do hope you liked the video. Please do give it a thumbs up if you did. Comment below, and why not start your comment with hashtag the Helix, just to show that you actually made it through to the end of the video. That does really help me. Please do share it, and I do appreciate your time here. So thank you so much for watching, and catch you next time.